Hi everyone, this is Jeanette from SQFI. We're going to go ahead and get started. So thanks so much for taking the time out of your day to attend this learning lunch. Before we begin, I wanted to remind you all of our upcoming International SQFI Conference in October that will be held in Atlanta, Georgia. For information on how to register, what pre-conference classes will be available, who else will be attending, and more, please feel free to go to the conference website. That's www.sqfconference.com. Some housekeeping rules before we begin the webinar today. If you have any questions throughout the webinar, please feel free to enter your questions in the text box located at the right bottom-hand corner of your screen. Our presenters today from Tri-Air Testing will do the best to answer all the questions when they can. Additionally, the recording of this webinar will be available on YouTube a few days after this live recording. You can find the link to our YouTube account in the email from me that you received earlier about this webinar. So today we've got some great information to share with y'all, and without further ado, we'll kick off the introductions with Christy Grozwinski.
Thanks so much, Jeanette. I appreciate it. I am Christy Grozwinski, Senior Technical Manager with SQFI. Thank you again so much for being on today's Learning Lunch webinar. This is the first webinar of the year, and as Jeanette said, we're going to be recording it, posting it to our YouTube channel, as well as providing it out to any of you who have registered. We're going to hold a couple of these Learning Lunch webinars, same format, kind of lunchtime here on the East Coast, or maybe breakfast all the way over on the left coast. But some of the upcoming topics, we're going to have food fraud, and one of the other ones is, of course, just flying right out of my head. So, but we have at least 4 of them in the works right now. I'm just ironing out some dates with our speakers, and we'll have those up on the website and in the SQFI newsletter as soon as we get it all finalized. Some of the other events that we have coming up besides the SQF conference in October is we're going to be showing up at some conferences such as the North American Summit on Food Safety in Toronto, GFSI Focus Day in Mexico. So if you want to learn about SQF and about GFSI in particular, we will be participating in that in Mexico at the Hilton Mexico City. And then we will also be at the Food Safety Summit at the beginning of May, May 7th through 10th in Rosemont, Illinois. So hope to see you there. Okay, without further ado, let me introduce our 2 speakers, James Scherer and Jonathan Sosita with Tri-Air Testing, and they're going to take us through some fascinating information and very practical information about compressed air systems in the food processing environment. And I'll hand it over to James.
Thanks, Christy. I'm James Scherer. I'm the Director of Sales for TRI Air Testing. I've been involved in air testing probably the last decade of my life in one form or fashion. And Jonathan, who's also on the call, is our Vice President and Program Manager. And he has extensive experience. I will do probably 99% of the talking today, and Jonathan will be here mostly for the Q&A in case there's anything too technical. He's a little bit better reference point for you guys at that point. So Christy already covered their upcoming events. So today we're going to talk about understanding, monitoring compressed air systems in the food processing environment. We really wanted to do it from a learning perspective and not have people out there just testing blindly because a specification or company document or something is requiring that testing. So to accomplish that, we're going to go through a couple learning objectives. We're going to teach you guys how to understand the flow of air through your compressed air systems, how to identify the potential areas of contaminations, where those contaminants can get into the system, review any applicable standards and regulations that are currently out for compressed air systems, and maybe discuss a few changes that we know are coming around. And the last thing we'll do is discuss the testing methods used to validate the safety of the compressed air system, how to collect all that data, keep it on file, implement it into your food safety plan, and have it available for any type of regulatory or CB audit that you guys may end up in. To accomplish all that, we're going to do a quick introduction of our company so you know who we are, where we're coming from. We'll go through a compressed air system 101, show you all the components and pieces, talk of sources of contamination. We have a quick reference sheet for standards from regulatory bodies so we can see a little quick side-by-side comparison, and then we'll help you guys build your test plan by going through the test plan requirements, showing you when and where to test, how to collect those samples, how those samples are analyzed on the backside, and then how to compile all that documentation and keep it in one place. And we'll leave a bunch of time at the end for QA for any of your testing questions, test plan development specifics. If you have them and you don't want to forget them, feel free to type them in the side, and we'll jump on it at the end. So TRI air testing has been around since 1975. We started out testing primarily for the Navy doing diving air and created some proprietary sampling methods, some of which we still use today, some that we've improved on and replaced. And over time we went from dive air to firefighting air to pharmaceutical industry, micro electronics, so your wafer guys, and then I would say recently, at least for our company in the past decade, into the food, packaging, and beverage industry. There's a saying at the top of this thing that says, "Why trust the knowledge of a brickmaker about jewels?" It's from a story, a book called The Richest Man in Babylon, and the whole idea of the story is a guy works hard, saves a bunch of money, and then invests with a friend of his who's a brickmaker to buy a bunch of jewels so they can make some quick money. And turns out the guy who makes bricks for a living doesn't know much about jewel, and they get a bunch of colored glass and end up with a worthless handful of beautifully shiny beads and nothing more. And so we always tell people, you know, there's a lot of talented people in your organizations. You work with a lot of other customers, but even a guy that knows environmental and ambient air sampling doesn't understand the differences to the compressed air system. And so there's some unique characteristics of compressed air we'll discuss today, and just take what we say with a grain of salt. If you've been told other things, we're happy to try to clarify that for you. We are an AIHA accredited lab. We're accredited to ISO 17025 standard. We're CAP proficient. CAP is a compressed air proficiency testing program that is a blind placebo type study. Basically, they send us a blind sample. We have to accurately detect what's in this sample, submit it back for approval. We've been doing that for
67 rounds.
67 consecutive rounds now, and we always come up at the top of the list. We specialize exclusively in compressed air and gas testing, so this is all we do. This is it day in, day out. So when you have any questions, we really know what we're talking about, and we're happy to kind of help you understand and analyze what's going on with your facility specifically. We are the official testing lab still for the U.S. military DCAT program. We test for the CDC and over 5,000 other customers actively throughout the world. So if it can happen in a compressed air system or in a compressed air sample, we've pretty much seen it at this point and can help you figure out what's going on. Additionally, we complete more than 30 certifications and customer audits per year. So I know a lot of you guys are used to audits. We basically do about 2 of those things a month from varying food, pharmaceutical, regulatory bodies, the U.S. government, whoever. It feels like someone's always rotating through our doors to check what we're doing. And then TRI is very committed to learning and staying at pace with our customers, trying to understand their needs. So our staff, my guys from sales down, we have people who are trained in HACCP, PCQI, very familiar with the SQF, FDA codes to assist you guys while you're trying to get answers. So this is the point where we're going to jump into the bulk of the testing, or the bulk of the presentation. Like I said, the purpose here is to teach you guys and to do learning. So some people who already have a little knowledge of compressed air, this will start a little elementary, but stick with us. We'll try to get through it pretty quick. I just want to make sure everyone has that good basis, foundation knowledge for the discussion that's going to happen in the next 20 to 30 minutes. So this is a schematic of a basic compressed air system with all the components. Ideally, either your maintenance staff or maybe even you will at some point have a similar diagram of your system. and we'll get to that kind of at the end with documentation. But what we're going to use this for is to kind of flow you through each piece in the same direction that air would flow through your system. So every compressed air system starts with one or multiple compressors. You can have 2, 3, 10 compressors, and they can all feed into a single system. Sometimes it's for redundancy. Sometimes it's just for capacity. When you're testing, it's important to consider the number of compressors you have to make sure that all the compressors are either online or cycling online to allow any sources of contaminants to be captured in that testing. If you have a single compressor that feeds a single tank, you don't have much to worry about. If you're a larger facility where you're staging 4 or 5 compressors, we have to take that into consideration. The whole purpose of your compressor is to pull in air from the atmosphere and then condense that to something higher than atmospheric pressure. In the food and beverage packaging industries, we see anywhere from 4,000 to 4,000 psi. It's a pretty wide range. 90% of you guys will fall in that 40 to probably 150 psi range. The 3,000, 4,000 psi is going to be primarily packaging companies doing some type of blow molding operation. So once that air gets sucked in and the compressor smashes it down and forces the pressure to rise, that process induces a whole lot of heat into the air. The heat in the compressor can run 400 or 500 degrees Fahrenheit pretty easy. And so that air is coming out pretty hot, and when it comes out that hot, everything that was in that air is condensed and is increased in the volume in the air. So your moisture, your humidity goes to 100%. You've packed as much moisture as you can into that air while you condensed and pressured that. Same thing with any other contaminant taken from the environment. So you'll run through your aftercooler, which will allow you to start cooling that air down and get rid of moisture. Half of the controls in a compressed air system is to remove moisture, because you don't want to put moisture into a cool, damp place that becomes a hospitable environment for any kind of growth. So we hit our aftercooler, cool the air enough that our moisture separator and our receiving tank, which is your next two, can handle it. The receiving tank will help remove the water by allowing the air to chance to cool down as it kind of cycles in and out of that, and then it'll condensate and basically everything will come down to the bottom of your tanks, and then it'll run through these drain lines, and hopefully you have an automatic drain valve. It's a little, looks like any other valve in a system, but it has a glass vial at the bottom of it that has a fill line on it, and that fill line is an indicator that it's overfull, and if that happens in your system, you'll start passing moisture or oil or whatever it's collecting down the line potentially. Most plants have automatic drain valves. They can get stuck, so hopefully your maintenance guys have a maintenance check for that. If we find you have a moisture issue, that's generally one of the places we start looking to try to figure out what's going on. Once the air is sufficiently cooled through all your your moisture separators and aftercoolers, will run you through your first set of filtration. Filtration is just designed to remove contaminants. Primarily, you're looking at moving particulate, both viable and non-viable, as well as removing oil from the system. Once you get the bulk of the contaminant and the air cooled, you'll hit your final dryer. The dryer is to get it down to your design characteristics. Typically, we see two types of dryers in food plants. You'll see either a refrigerant dryer or a desiccant dryer. These things can be multiple stages. They can get a little bit more complex, but the basic ones are just going to be a simple refrigerant dryer like an air conditioner in your car or house, or a desiccant, which is just a bead material that helps remove that moisture. Once we get it dried out to the appropriate level, that's when it actually enters into your piping that runs out into your plant. And as it runs through that plant, it'll come down to your production areas, where generally you'll have some kind of after filter, point of use filter, final filter, just depending on the verbiage of your maintenance guys or design team has used when they built this thing out. But this final filter is designed as your final safety step to make sure that you have no particulate getting past or oil that can basically scrape past into your production, which is going to be your final point of use. Down here at the bottom, these filters are recommended at 0.1 micron for most food and beverage facilities, and a lot of that comes out of an old FDA reference where it used to be 0.3 micron. for removal of microorganisms that we're mostly concerned about, and it's based off of their spore size. And now, because those are a little bit harder to obtain, 0.1 is kind of a default in the filter, so it seems like everyone's adopted 0.1 micron just to make it easier to actually implement that use. So now that we kind of have an idea of what this air system does, it comes in, compresses it, cools it, dries it, cleans it, and gets it out to your point of use. You can start seeing an idea of how this air is delivered, pure or clean or whatever word you want to use. The problem is most facilities will say, oh, we're not worried about oil in our air because we use an oilless compressor or a water-cooled compressor, or our compressor has food-grade oil, so we don't have to test it. And ideally, I mean, it should have food-grade oil, and in an ideal environment, when its maintenance has been upkept and everything's functioning, it shouldn't contribute any contaminants with those precautions already taken from the compressor itself. But the problem is we have two sources of contaminants. We have contaminants that are produced within the compressor, and then we have contaminants that are produced from the actual intake of the air. So this is where it gets critical to figure out, where's my air compressor at? Did they locate it in a room where it's by itself and it has a fresh air vent that goes outside to an open air area of the building, which is ideal? Or is it located outside on a compressor pad right next to our loading dock, and they're parking big rigs next to it running all day, and now we're sucking in all that into the air and delivering that to the system? Is it just in some extra space they found because of growth and expansion, and now it's stored with all your ammonia and chlorine and whatever else is in the building? So all that environmental air that gets pulled in, anything, if it's the exhaust from a big rig, gets condensed down to a much higher volume than what's in the atmosphere, and then passed down through your system. And so our food customers, not too many look at carbon monoxide, carbon dioxide. We're not generally breathing the air. It's not usually coming in a high enough quantity to affect the air in the maintenance facilities. So we generally start looking at these last three columns. Gaseous hydrocarbons, depending on the product, and again, your risk analysis we may take. So from the intake, it's very easy to pull those in from any chemical plant nearby, manufacturing plants, motor exhaust. Inside the compressor, if it starts to burn hot, it'll break down those oils, food grade or not, and you'll still end up with this influx of these hydrocarbons through your air. Your particulate and your condensed hydrocarbon, this is more your liquid oil versus your gaseous vapor-like type oil. This is just anything that's sucked in, so dust, pollen, microorganisms, anything that compressor can suck in, it'll compress down, and if those filters aren't doing their job or you don't have appropriate filtration, then you automatically start building up those things and pushing them into your product or down onto your lines or wherever else you're using your air. Even your guys, maintenance guys, this is the one that should be the concern. If you're looking for a way to get buy-in from your maintenance team on testing, this intake side should be their concern, because when they're using this stuff for pneumatics, for moving belts or driving valves, the particulate in the water that's pulled in, if not filtered appropriately, is what will jam up those valves, shut down production, cause machines to run slow, or sorters to miss fire and not remove product from the system. So generally, if you need a buy-in reason from maintenance, this air quality check is usually a pretty good way to balance what they're doing and what their needs are with what yours are. And then inside the compressor, same thing. Once it starts running hot, we start breaking down. That can pass through, but even bigger, your piping in a system and any type of solvent that they've used to repair it or to replace a thread or cut in a new production line or a new drop, if they didn't clean and blow that line out appropriately or isolate it correctly, all that metal shavings and everything from those adjustments will pass down those lines and out to the rest of your production facility. And depending on their weight and your pressure, can take quite some time to get cleared out of there. And the last area of concern is water from the environment. Obviously, it's humidity. Like I told you, when we compress that down in any compressed system, it's going to go up to it's going to go to 100% humidity relative, and then we'll start dropping it as we cool down, and your dryer will get the rest of it out. Inside your system, Moisture can remain in the output when your separators, your drain valves, your traps aren't working. The other place we'll see moisture get picked up is if you have a larger facility and you're going from plant to plant and your compressed air is centrally located and you're running through a 2, 3, 4-inch pipe underground. That transition from conditioned environment to an unconditioned environment is going to allow a pickup of moisture sometimes. And so generally what you'll see is in the next building you'll have an additional dryer and separator to help control that. So it's a lot of information to try to show you guys where the risk is coming from, where those contaminants can be picked up, and why we're even concerned with the compressed air. There are a few standards that in the compressed air world we use, and then there's a few regulations that will relate to you guys. The number one standard that people reference in compressed air is ISO 8573-1. It's the only international standard for compressed air testing. What it does is it specifies classes of compressed air with respect to particulate, water, and oil, and it basically gives us our test methodology methods that are validated by an international community to say this is how you should collect the sample, this is how you should analyze the sample, and here's a rating system for it. Nowhere in these ISO standards is there a specification that says you must meet Class 1 air or Class 2 air. They even have whole subsections. Chapter 6 is on gaseous contaminants, and they make no reference at all of classifying it. Section 7 is on microbiological. It outlines, again, a sampling method, but never does it qualify what a good pass-fail per industry spec is. Currently, we'll get to it in a second, but there's really no one out there telling us that right now. And so what we'll see from the ISO standard is they'll tell us how to collect the sample, they'll tell us how to analyze the sample, and then they'll give us just this overview of where to rate it. There are compressor companies, filter companies, other labs that will recommend you push yourselves into these upper limits, but honestly, a lot of times it's unnecessary. I mean, if you have a high-risk product, you're ready to eat, you're doing, babies or elderly, these could be more applicable to you. But the bulk of manufacturing, processing for food, this would all be a little bit excessive for air provided. To give you a reference point, in a sterile environment, a medical device manufacturer that's making a pacemaker that's going to be inserted in the body in a aseptic sterile environment, those guys will test to what they call an ISO 7 clean room standard, which loosely correlates to a Class 4 air in the ISO 8573 standard. So what we try to focus on, we use the ISO standards to help us create our collection methods, our processes for analysis, and what we try to focus on with the end users, the food and beverage packaging companies, is what regulatory bodies, what are the certification bodies, what are we being asked to do currently. And so we've created this chart that kind of shows the three big ones that we get asked most about here in the U.S. SQF, current edition's the 8th, BRC, FSMA, and then we've come down here and we've made a couple indirect and direct product contact recommendations, and then we've also compiled just an average of everybody in the food beverage sector and what those ranges that we're seeing are that they're asking for reporting, not necessarily what they're showing on the reports, but what they're asking for their pass-fail type report limits. So SQF, I think I have broken out in a couple slides, so we'll go through that, and it aligns very, very well with any of the FSMA requirements that are out there. It's taken from GFSI, so it aligns very close with all of that. And then any of these recommendations that we make here will meet or exceed any of these other requirements. So the SQF current edition has several sections that reference back to compressed air tests. So module 11, 12, 13, they all basically say the same thing. I'm not going to read all this to you guys verbatim, but basically what it's asking you to do is make sure that it's clean and presents no risk to the food safety, and that it's regularly monitored, and the quality is acceptable for food safety hazards. And it's talking about, you know, compressed air and also compressed gases used for like modified packaging, so your nitrogens, your carbon dioxides, things like that. And then the recommendation is generally test a minimum of annually, and consider particulate water, oil, and any type of microbiological contaminant that could be present. And again, it's all a risk-based approach. There is some clarifying information on their website still available for people that want more. Again, the biggest thing here is the recommendation for a 0.1 micron filter, and that your sampling methods should be appropriate. You should be collecting, of course, microbiological and aseptic method, and that you should be using adequate sampling equipment for compressed air systems. This is what I was mentioned earlier, where atmospheric sampling is not always appropriate for, generally not appropriate for compressed air systems. The difference in pressure and flow from a compressed air system, just the nature of it, is going to render most atmospheric testing methods useless. The air is either going to blow by the sampling media that you're trying to collect on, or through Venturi effects will get just disseminated throughout the air, so at best you'll have a blended air sample. And what you really want to focus on when you're sampling with compressed air is collecting that in a controlled, sealed environment, so that you know you don't have any cross-contamination or possibly bleeding out contaminant and not even capturing it on your sample media. So we've kind of rushed through a lot of information about the 101 of a system and the specifications and the regulations to try to give everyone a good baseline to understand this last part, which is honestly the more important part of the webinar. How do we take this system that we have and these requirements that we have and build that into something that we can use? The thing that drives me nuts the most is people will call, test, get a report, and have no idea why they're testing, what they're testing for, or honestly what the report even means once they get it. And generally it's because they don't have the basic functional knowledge of the system, or the understanding of what they were originally looking for, because they didn't come up with this test plan and they didn't analyze or do a risk assessment of their system. And so this process we're going to walk through is just kind of a good overview of how to get through all that, and then how to get to the end result and what those results actually mean, and so that they're usable for you in the long run. So test plan development, current quality guidelines is generally a great place to start for you guys. What I mean by that is any corporate documents you guys have on your internal quality specs. So I pull all that, whether it's environmental or anything else, bring that in. If you have an air quality spec, if you're fortunate enough to have that, great, reference that. If you need help understanding it, send it over. Our team can help read it for you and break out what it means to you. Any customer requirements you have, if you're supplying to somebody else and they're doing vendor verifications or supplier verifications, they may have a requirement for you to meet certain standards if you're supplying product to them. And then, of course, any of your regulatory certification body requirements will help us determine what your actual specification requirements should be in the end. So once you have that kind of front-loaded, you know why you're testing, what you're looking for, whether you have a final critical limit or an actual final plan, this will give us basically the research piece of building this plan. After you get that, we can look at your maintenance guidelines, internal plant stuff. Does your maintenance team have a diagram of your compressed air system already? 90% of them will. It may take some digging, but it'll be around. It's a good document because it can be used to draw up your system diagram later. It can identify your points of use, types of filtration, where this maintenance should be happening at. If you're fortunate enough to get that and you go through, verify it. While you're verifying it, make sure that the maintenance checks are happening. You know, every filter in a compressed air system has a lifespan, just like any other filter. Your oil filter in your car, you know, every 3,000 or 5,000 miles we're replacing those. The air filter at your house, every 90 days you're pulling that thing out of your air conditioner and replacing it. Same thing with compressed air systems. The guys who manufacture those filters go through their own processes, and they come up with a life on those, 6,000 hours, 1,000 hours, 4 months of normal use, and they'll define all that. So just make sure that you have that information and that those guys are doing that maintenance to that, because these are the preventative things. The control that is removing that contaminant, potential contaminant from our system. So just as you go through the maintenance log, go ahead and verify that stuff, which is not going to probably make you popular initially, but it'll give you a little bit more peace of mind, and it'll let us get a better idea of the actual risk that the system has. And then the other place to look is at your other utilities. Most people are testing water because requirements have been more stringent for longer. Most people are testing steam, hot water. Look at the frequency of those testing. Look at how many test points are we sampling those at currently. Is this something we're doing annually? Is it something we're doing daily? What's the risk that we're identifying there? And then see how those translate to your air system, and we can kind of marry all that up so your utility systems are all basically on a very similar plan, and your whole risk assessment stays in a very logical manner. You're not doing some one-off weird standard testing just because it's a system that wasn't originally considered. So after we have that background information, we're going to want to identify the uses of the compressed air in your system. Again, this is part of the risk assessment. The more direct product, the more the air touches the product, the more risk there is that if there was a contaminant, it would spread to the product. So in order of risk here, direct product contact, air that comes into contact with the product or the interior of a product package is generally considered direct product. It's the highest risk. You can also consider in this exhaust from certain pneumatic components. So if you have a bunch of pneumatic valves that are just exhausting and blowing right onto the final product line before it goes to packaging, well, all that exhaust air is now coming across the top of the product, and so you should look at your compressed air in that area. We have a couple of guys who will get to this final, say we have no contact, we just have processed air, which is air used for valves, actuators, pneumatic components, so we don't have anything to worry about, so we're going to say we have zero risk. For the most part, that could be true as long as they're considering all their exhaust ventilation. If it's closed off, sealed, and it's not venting into the product, then there's a good chance you can say, hey, we just have processed air, here's our system diagram, nowhere is it coming in direct contact with the product, nowhere is it coming in indirect contact, meaning we're not blowing off conveyor belts after a CIP or something to do the final dry, and then the product's going to run across that surface later. You might be able to risk assess it out completely if you're really in one of these non-contact or process air type situations. So once you identify the type of air contact, you're going to have an idea of where your points of use are already. Because the only way you're going to figure out what type of contact is to figure out where they're at. So as you're figuring out these points of use, what you want to record for each one of these is the location of the point of use, and it could be by valve number if your maintenance team has decided to label each valve by number. It could be by line number or equipment that it's hooked up to. You just want a reference that is reusable and common knowledge in your facility. So don't come up with a custom naming system for these valves and then expect someone further down the line to be able to come back and reevaluate or even apply this program. So try to use common naming conventions. If they don't have them, get with your maintenance team and you guys come up with it at that point. They generally have a pretty good system for naming valves. The other thing you're going to look at is any additional filtration that's hooked to those locations. So your point of use, your final filters, is there a 0.1 micron filter in place there? The availability of a test port, is there somewhere I can hook in test equipment to sample and collect this analysis? And if so, what type of connection is that? Again, you're going to have to get some help probably from your maintenance guys if you're not someone that's very familiar with this. But getting this basic information is going to make this process a little bit smoother for you in the long run. So after we've done all this legwork and research, the last piece is identifying the compressor and the system components from there so we can help make sure it aligns with whatever specification requirements you have. It's pointless, and we get people to call in all the time. We just want to test our air and see what it is. Well, we're happy to take your money and let you just test blindly, but it doesn't benefit you at all. If you haven't done the fundamental work or don't have the knowledge when we ask you questions, you know, you may not even need to test because you may not have, we can tell you, hey, we have no filtrate, we don't have a dryer, we're just running it straight through the compressor. Well, we can tell you you're never going to pass any reasonable moisture spec. What you need to do is address the drying in your system to at least a minimum standard. And so sometimes we can get you corrected without even having to test initially and then use the testing to kind of validate the changes. So we worked backwards to forwards. We looked at the overlay of the plant, how the system's laid out. We worked from the point of use, because it's generally easier to figure out where air is being used in the plant. And then we work all the way back and we identify type of compressor, filters, dryers, what type of piping. Is it stainless steel? Is it aluminum? Or is it an old cast iron, which is going to flake off and have a higher particulate risk, and just something we need to be aware of when we're doing our risk assessment. And so keep compiling all that data, and then we have to figure out, okay, here's our risk. It's pretty low risk or it's high risk because we're a ready-to-eat product and we don't have any moisture separators or filters. And then you come down to figuring out your sample collection. How are we going to test them? We know what the system does. We know what our risks and what the possible contaminants are. We know what controls we put in place to limit those and where we're using the air. And now we have to figure out how and when to collect this sample. When is generally specified by your certification or specification that you're trying to meet in conjunction with your risk assessment. So if the certifying bodies and FDA or whoever's saying minimum of annually consider this, well, we know at a minimum we're starting. That's our starting point. We're looking at least annually. If you're changing out filters every 4 months, then you probably need to align that with your maintenance cycle and look at your testing on a quarterly basis when those filters are changed out. Where to sample should be pretty easy now because we've looked at the point of use, so we know we want to test down by those point of uses, and I'll explain that a little bit more in detail in a second. And then we got to decide which of those points of use we're going to test. Are we going to test all of them, which is a great way to develop a complete baseline of air quality, and it's very common practice in our pharmaceutical industry. Not something we see, honestly, very often in the food industry unless you're producing with sterile air. Are we just going to test at the end of the line? The end of line testing is the point furthest from the system, from the compressor, and it's generally what we see people doing in the food industry. They'll test that last furthest point of use on a line, and we'll say, hey, this is representative of the rest of this branch or the compressed air system in a smaller system. So if you have 3 production lines, maybe you're looking at testing 3 points, 1 at the end of each production line, and if those points meet your air quality standard, you don't have any further testing to do. If one of them's off, well, then we need to start doing a little troubleshooting and isolate where that extra contaminant's coming from, and it may require a little additional testing at that point. And then the final option, which is generally for your much smaller operations where you have a compressor running straight out to one piece of equipment and that's all the compressed air is doing, is just a single sample. The systems aren't large enough to worry about how the piping's branched or ran. It's only got a single purpose in the building, so a single test makes options. The last option for really large facilities who don't want to blow a budget testing every single point of use, but still want to have a good control and validation of their system annually, is going to be to do a percentage-based approach. You're going to say, hey, look, we have 32 points of use in the facility. Every quarter we're going to test 8 points of use, and that way over the course of the year, we've tested all 32 points of use and we know what's going on in our building. That approach is pretty commonplace, honestly, in anyone using like a more sterile type clean air environment or pharmaceutical air, and maybe if you're in a higher risk when you do your risk assessment and the appropriate model. But 99% of you guys are probably going to end up in this end of line type testing where you're just looking at what's going on in the whole system. So we've talked a lot about where to sample, what to sample for. I figured I'd give you guys an example of what the sampling equipment looks for. This is TRI's equipment. We designed it and have been improving it for the last 40 years, but basically it ties directly in with a 1/4-inch female NPT fitting. That's that brass fitting all the way to the left side in that first picture, and it's a very common fitting that should be easily adapted into your guys' system out in the plant. And then the picture on the right just shows the unit opened up, and that white disc inside is the actual filter that we'll use to collect your particulate and oil mist samples on. Same type of filtration that you're putting in your system, just multi-layered, compressed, and at a much smaller micron rate than what you're going to have installed to allow us to capture everything. Once we've done that sample collection and we've figured out what your limits are, we've gotten you a report, that's the part where most people fall off. They've done the work, they've checked the box, yes, we test our compressed air, but then they stop. They don't finish the process and do anything useful or meaningful with that analysis. The final step really is coming up with a way to use that data that means something to you. And so in the food industry, and honestly most non-sterile industries, what we see when there isn't a hard specification, so you're not getting told what your breathing air is, like OSHA tells you exactly what you have to meet for breathing air, then you have to do one of two things. You have to come up with a risk assessment, look at your baseline study, that first analysis you took, look at all the components, your dryer, filter, what they should be controlling at, what the design of our system intent is, and then establish a critical limit and compare your results to that critical limit. Set a deviation, and if it exceeds that, something's wrong with the system. We need to make correction and we need to retest. The other option, and in the food industry we see this a lot because most plants have been running for so long without testing air, is to create a historical trend analysis. You may not have the historical data currently to allow you to do that, but what you do have is a ton of other data that shows that the air has not been contributing to a safety issue or a quality issue or a stability or shelf life or any issue to the product itself. And so you have environmental testing, final product testing, all this stuff that shows, hey, the products that have been going out for years with the use of the air that we currently have is good. And so we know that it's not contributing contaminant. So we take this first sample, we make that our baseline and say, okay, we know if our air stays here that it's good, it hasn't affected the quality of our product or safety of our product in 15 years. So as long as we stay in this window that we're in now, we're happy with that. And so a lot of plants will take that first study and they will use that as the first point on their historical trend analysis, and then future testing will compare to that. A lot of times what we'll see is people do that initial test in triplicate, so they'll test that same point of use, the end-of-line point of use, over the course once a week for 3 weeks or once a day for 3 days, just depending on how high a production run you have, and then they'll kind of take an average of those, and they'll have a high and low from that, and they'll say, okay, this is where our air needs to stay, and that's where they compare it in the future. So those are really the two best ways in the food industry to kind of use that data to prove that that air is still in control and it's still doing what we want it to. The whole purpose of this testing is just to make sure that that air is still in control, that those filters and dryers are functioning as intended. This is a pretty complex slide that basically shows all the things we can analyze. It'll be available on the YouTube channel when they release this. If you guys have more technical people that want to read through it and have questions, we're happy to answer all that, but we're kind of going to blow through the highlights that will matter to most of you. So oil mist, condensed oil, we can test that down to a really low limit. It's 0.0001 milligrams per cubic meter. It's essentially an oil-free rating. Moisture is tough in compressed air because it's tough to transport an air sample without it picking up or losing moisture content due to a bunch of environmental conditions. So we use a color changing indicator tube that we send out, and you actually make that reading on site and record your reading and then send it back in and we validate it from there. From that we'll calculate your dew point, so we'll be able to tell you it's running at 0 degrees Fahrenheit or 40 degrees Fahrenheit, which is acceptable for a refrigerated dryer system. So if you know you have that, hey, we say, yeah, that's in line with using a refrigerant or a desiccant system. It doesn't look like you have anything to concern yourself with. People who are more susceptible, who aren't running the right oils yet, or have their compressors located in a higher risk environment, like near the loading dock, halogenated hydrocarbons, oil vapor, oil mist, can also be collected with a charcoal tube, and we can inspect that and kind of give you a rating for that also. And then the last thing we typically look at for food is, of course, your mold and bacteria sampling. We use a kit that's very similar to the one I showed you guys, except the front whole half of it is detachable, and sent out to you in an aseptic manner. It's all double bagged and vacuum sealed, and you'll hook it directly into your system with the input fitting attached on it already, collect the sample, rebag everything, and send it to us. And then if you have multiple sample points, you'll get multiple of those input fittings with the filter already built into it. So it never has to be open. Nobody ever has to handle the filter. It's just a quick connection, test, reseal, and send it back to us, and then our guys in the lab will take care of it from there. The difference in our microsampling process and some of the environmental stuff, you can't just set a plate and blow air over it. When you do compressed air testing, there's a couple things I mentioned. One, you want to make sure that you're in a closed environment so that you know what volume of air and that nothing else is coming from an outside source or getting bled off and mixed with an outside source. The other thing you want to be able to do is measure the amount or volume or flow of air that you're sampling. And so our kits with the pressure gauges and our flow curves allow us to measure out and give you a reference volume. So early on when we talked about that ISO 85.3 standard, everything in that basically references to a cubic meter of air. So that's what we're trying to do, is get a cubic meter of air across this media that we're collecting, regardless of what type of media it is, and use that as your reference volume. So we won't just say you have 50 CFU, less than 50 CFU, so you're no growth, or less than 10 CFU. It's all going to be referenced back to a cubic meter of air, which means something in a compressed system. And if you're struggling with that, we can always help you guys define that and work through that compared to your other testing. The final part of this is packaging all this together with documentation. And so there's several things we need to do for documentation, and it actually looks like these slides got flip-flopped. So documentation, you're going to want a system diagram. You're going to want some kind of system information sheet. That's where you're keeping types of compressors, filters, what's the point of use, what's the maintenance schedule. You should have some kind of SOP or something from your safety plan. We have samples of all this stuff we can send out to you guys if you need. Once you get all that done and you have your SOP written up with your sampling points, you should have your testing report. You should have a lab certification from a certified lab. There are 2 of us in the U.S. that are certified that I know of, and probably about half a dozen that aren't, that kind of do it out of their truck. So just be careful when you're doing that. It should be no big deal for a lab to send you a copy of their certification. And then whatever you're using to compare those results to, whether it's a critical control point, if it's a historical or a trend analysis, you should have that data included also. When we go through this real quick, so your system diagram, again, type, location of compressor, filtration, dryer, points of use, and sampling points. And what you're going to end up with is a document that looks something like this that will have a legend or a key that goes off these numbers. So we label number 1, our backup compressor. There's going to be an information sheet that says it's an Ingersoll Rand, blah, blah, blah. This is a 5 micron filter. This is a 1 micron filter. This is, you know, a 0.5 micron. This dryer is rated to operate at 0 degrees Fahrenheit. So all that data you collected, this is where you'll make it relevant. All the way out to it's coming into the building, and now we're running out. Here's our points of use. Line 1 and whatever this room 20B is, line 2, line 3, and line 4. So we have 4 lines that are running parallel, so we'll probably end up with at least 4 sample points in a system like this, one at the end of each one of these lines after the final filter. In this case, the whole line has a final filter, so this would probably be your 0.1 micron filter, and all this air would be cleaned to the same purity. We test at the end of each line just to make sure that these pipes aren't adding any contaminants on their own, because they're unique to each line. So this is just a simple SOP. We have a copy of them. I'm happy to send you guys. Basically does the risk assessment, kind of outlines everything. I'm not going to go too much into detail so we can answer some questions. A copy of a sample report, again, we're happy to send you guys so you can see what they look like. These can either be a pass-fail type thing if you set limits, or it could just be something quantitative, just reporting the actual data from the source point. If you have your own limits that you're going to compare it to or a trend you're going to do. Certifications, like I said, you should be able to get those without any issue. This is a trend analysis. We have an Excel form we can send if you guys need something or you're having problems creating one. And that kind of brings us down to the end of the presentation. I know it's a ton of information that we tried to jam into 40 minutes. So if there's any questions, which it looks like we have a few, I can take those now, and then if there's anything super specific, we'll probably take your information or give you our information, honestly. You can reach us through a contact form at airtesting.com, and we'll answer those one-on-one.
Fantastic. Well, thank you so much. That was a ton of fantastic information, and I literally just heard you guys last week, and I already learned something new yet again. So anyway, so one of the questions that I have, some came directly to me, and then some I think you can see there, but one of them is the SQF code edition 8 added the testing of other gases. And so how does this differ from testing air? Is it any different, or what should be done differently to evaluate and test those other gases?
Sure. So I can't speak for you guys, of course, at SQF, but I think the addition is pretty smart. I mean, if you're using gas instead of air for filling headspace or modified atmospheric packaging or something like that, and it's going to sit in the product, and it's one of the final things injected into the package, you want to make sure that's clean also. The sampling process is the same. You hook into that system the same as you would hook into a compressed air system. The analysis on our side, if we're looking at particulate water, oil, hydrocarbons, it's primarily the same from the sampling point of view. The analysis, there's a little bit different formula because of molecular weights that these guys calculate out. The additional thing I would recommend people have when they're getting their gas, and hopefully most people are already getting, is that COA from their gas supplier if they're getting either cylinders or dewars of gas delivered. If they're using nitrogen generation systems, then there's a couple different specifications we can compare those to make sure they're functioning correctly. There's some USP standards specifically for nitrogen generation that we can share that may be more appropriate than maybe what's in the SQF or FDA or FSMA or something like that.
Okay, very cool. I just want to remind everybody you can type in your questions into the Q&A box, and we'll pick those up. So another question that I have, say from an auditor's perspective, what are the key areas that they should look for, say from a compliance perspective, you know, where within either their procedures or what they're actually doing should the auditor be looking for, and that would be useful to the site to know as well.
Yeah, absolutely. So we talk to auditors quite frequently because they're not usually compressed air experts either. And what we generally tell these guys is to take it from the same approach you take anything else in a plant. Have these guys taken the time to research the system? Have they done a appropriate risk analysis? Have they made the justification for why they're testing this? Or are they just showing up on audit day with a certificate that says, hey, I tested my air? And so what we generally tell those guys is if they're following the same processes that they're following with the same detail, they're following everything else that's allowed them to get to a point where they could even qualify to be SQF certified, then they're probably on the right process. So is the process logical? That's basically what these guys are taking this point from. They looked at the system, they said this is their risk, this is what it's designed to do, they've tested it to prove it's meeting all of those requirements, and they have the documentation to show all that. There's nothing else for them to check at that point.
Okay, all right, thank you. I have one that actually kind of follows up on that, a little similar. It says SQF code edition 8, remove that focus specifically on microbiological contaminants and went to a more general food safety hazards. And so where do I start evaluating my system for the risks? You know, what risks am I looking for? And I know you mentioned a few in here, but, you know, like where's some of that, where do you begin kind of a thing?
Yeah, and it begins, again, from, it's tough to say specifically, so we have to keep it general, and that's the reason why FSMA, SQF, GFCI, GMP type stuff is very general, is because it's hard to say universally this is what you have to meet to be safe for compressed air, because we don't know what your system's doing, what type of piping, what the exposure to the product is, what the stability of your product is, what further processes your product's going through. And so it's really hard to say meet this and you're good. And so you have to take a risk-based HACCP type approach to even your compressed air system. that list of contaminants in the early slides will show you everything that can come in, the particulate, the oil, the moisture. You're in a hot, because of the heat that is generated when you compress air, so you get this warm, moist, dark environment, and that's generally where people start getting concerned with the microbiological. But honestly, the bigger concern is anything that you're testing for and concerned with in your environmental air is what you should be looking for in your compressed air, because that's what you're sucking into your compressor, and you're taking all of that, and what fits in, let's say like a cubic meter is 9 feet by 9 feet by 9 feet, so what fits in your office, your normal office, is getting smashed down and compressed into something much smaller at a higher density, and so all those contaminants that were in that big box of air are now in that little package that's moving down your compressed air, and that's where the microbiological part came from initially. It's almost impossible for me to say without a conversation what exactly someone should be looking for specifically, other than tell them, hey, you have to do a good risk assessment, and here's the risks: particulate, oils, water, and microbiological. Those are the big four that we're going to worry about probably in the food industry.
Well, that there is pretty useful to know. Honestly, I mean, I have to say from my own perspective, I've never think of like the hydrocarbons part of it. I think, oh, that's what the filter is there for, isn't it? So that to me was very useful to learn about that, and that chart is very handy as a good starting point to understand what it is that you're looking for. I don't have any other questions on my end. I don't know if you guys got any questions that came specifically to you. I don't know if Jonathan's monitoring that for you.
I don't have any. We're good. Just that 10-point regularly monitor.
Air quality CFS. So yeah, it's similar. There's a couple of questions we've gotten that are very similar to what we've discussed. You know, regularly monitored for quality and applicable food safety habits, what quality standard would apply. Again, these are going to be individual risk assessments. So, I mean, it's all, and that's what we see honestly on, you know, the 100 or so phone calls we get a month. That's usually the primary question. It's what's the standard I should meet, and the answer is you're going to have to do some work to establish that standard for yourself. We're happy to help you with all the learning and the information and the research and the kind of evaluation of what you've done, but we can't tell you for your specific product what is the standard that I have to, what is the actual, is 1 micron or 1 milligram of particulate okay? Should we test down at 100 or 50 or 10 CFU? We have sites that are sterile air where they have us come out and have our techs come out and use laser particle counters to look for very, very clean air. So on a case-by-case basis, we'll be happy, myself or Luis or someone on my sales team, to answer those questions. If we get technical, we'll bring in Jason, Jonathan, Dr. Gala. Those guys are happy to kind of broach that. And that's kind of, I think, it for questions that we see on our side.
Okay, yeah, me too. All right. Well, I suppose that's a perfect place to wrap it up and end this webinar. We thank you so much for this fantastic information, and as we said in the beginning, we are recording this webinar, and we'll send the link out to everyone who has registered, so they'll have access to this, and then we put it as well onto our YouTube channel. So I want to thank the gentlemen for being on this call and TRI testing. We'll see you at the SQF conference, won't we, if I'm not mistaken?
Yeah, absolutely. Atlanta, we will be there.
All right, yes. So if you have the opportunity to go to the SQF conference, you will be able to see these gentlemen from TRI air testing there at the SQF conference. And with that, I think we'll go ahead and wrap it up. Have a great rest of your day.